So I can post the next homework assignment, I think, today. I think previous one was pretty straightforward, right? I can also post its solutions. So right now it's more like physics 1, but very quickly we will switch to the real stuff. We have to go through this drill. Disconnected. Internet. Okay. Oh, 38 and 10:39. Okay. We still have, I think, 60 seconds. I think we can start. Okay, so last time, this is where we left, right? I just wrote all the formulas for a simple projectile motion. If you want to take a picture, quick snapshot, you can, because the next slide we have an example that I will be doing. So horizontal, vertical, these are all the formulas all of us decided with, right? Again, x double dot equal to 0 for your horizontal motion, y double dot equal to negative of g, x dot is a constant, y dot, we have this beautiful formula. You see this plus sign, don't get misled with this plus sign, because you look at y double dot, there is a negative g that is setting, so you will plug in here. Wherever you see a nod in my slides, you will see that I am talking about the initial, right? Y dot nod means I'm talking about VIY. Okay, so far so good. Did I write here x dot equal to constant, which is equal to V naught cosine theta? Okay, this is your example. Why don't you do it? So we have somebody who is throwing a basketball right through the basket. You see the initiation, that little point. So this is where the hands are, right? This is the point from where the basketball leaves the hands. You can see a distance of 2.5 feet here. Makes sense. Probably the guy is around, the basketball player is somewhere around, I don't know, 6'6" or 6'7". So makes sense that wherever his hands are or her hands are, the basket is 2.5 feet above that. So what are my known? I have range of the shoot 25 feet. I have theta equal to 50 degree. Delta y, anyone who wants to tell me what would be my delta y? 2.5, right, with a positive sign, because the basket is 2.5 feet in positive direction from her hands. What are the unknowns? I think the time of flight is unknown for me. I think I have what else? I have psi as the unknown, because the basketball really needs to enter into the basket at a particular angle, right? Otherwise it will not basket. And the last unknown, anyone? What are my unknowns? Velocity, right? V naught. So why don't you do it? Okay, for those of you who just entered the class, why don't you take a picture of this quickly? If you are planning to, if you already have your notes, that's fine. Take a picture so I can move to the next slide. This is from the last slide and the last class. Nothing new. 7, 6, 5, 4, 3, 2, 1. Okay, do it. And of course, I will do it in parallel with you, because just a quick comment for Baran. Baran, can you hear me? No, I will tell you. G is not 9.81. G is I will tell you, please. Yes, Hoja. Okay. Yes, that is a good comment. Thanks for pointing it out. Please, G is 32.2 feet per second square, because this is your first or second time that you are even going through British units. 32.2 feet per second square. So V X is a nice and beautiful V naught cosine 50. Then I have a VFX equal to okay, Vx, then VFX equal to Vx, because it's unpowered flight. It's oh, that's not good. V naught. I even don't know V naught. How can we even start this problem? Okay, I think the range can help us probably. Probably we can go back to the formulas 6, 5, 4, 3, 2, 1. Where is range? Somewhere should I range? Where is the range of the flight? I think this one is the range of the flight. Looks to me. X equal to X dot T. I think so. Range. X equal to X dot. S is equal to VT, right? And
X dot T is V naught and we don't
know. Exactly, right? I know. So X is, you are right, actually, 25 feet, but I have to start from somewhere. X dot, as you said, it's unknown. So V naught cosine. Okay, please don't get confused. Why are you writing here X dot and then you are writing this? So X dot is Vx actually, the X component of velocity. You can use one set of notations. I keep on switching. Vx and X dot is the same thing. Okay, that's it. Anything else? Okay, V naught is unknown and T is unknown. Do you have any plans of
We can use 2AS to find final.
No, 2AS to find the final velocity. But final velocity in the X direction is known. I think we can use this 2.5 feet. No, 2.5 feet. T is equal to
1.
I think I have 1.3. So
1.00.
no, it's 1.3. I have a quick question for you. How did you use this one 2.5 feet? Because
I multiplied with the horizontal distance that the ball has taken and deducted by the gravity's.
Got it.
You understand?
I got it, but I only have one problem with that. Probably if you use this one, I think it will be better. No, I think I will see your solution again. Delta y equal to let's go back. You see this one where I talked about the vertical distance. Oh, come on, where is it? Did I even forget about it? I think that I should have written this. Delta y equal to, you can look at your notes, minus half GT square. I think I forgot that. Plus V naught y t, right? I think I forgot to write this. So now you can use this delta y equal to minus half GT square plus V naught y. So V naught sine 50 t. So delta y is my positive 2.5 feet, no? And minus half GT square is minus half 32.2 t square plus V naught sine 50 t. So I think we are running in circles if we don't solve these two, because we will keep on encountering a t and a V naught. So two equations, two unknowns. Why don't you crack this one? Are you getting my point? So this is a 25 and this is a 2.5. If you have a feel of the problem that I had this 2.5 feet that was given to me, right? So I use that one. Delta y is equal to minus half gt square plus v naught sine 50t. It gives me one equation, and the fact that there is a range that is given to me, the range of flight, that is s equal to vt. And why did I go for a v naught cosine 50t? Because the fact that it is covering 25 feet is only because of the horizontal component of velocity. The two equations to one of why don't we solve this for me? No, final velocity or the velocity at the top of the curve. Oh, you mean divide? Yeah, not at the top of the trajectory. No, the result is something divide. I think it's one because it is traveling in the horizontal. Yes. So we have good equation. It is closer. I think I have 1.33 in my notes. How did you get 1.033? Can you show me that equation? Are you sure? Focus about. That's fine. Okay, yeah. Okay, I think everyone is on the same page with me, right? So let's finish this. I have 1.302 in my notes. So I'm getting a t equal to 1.302. Done. I just wish someone can double check this for me. And I have a v naught of no idea. What is v naught? That's not good. Yeah, who said that? This is correct. Yes, good. I think you're right. 29.9. Yes. 29.9 feet per second. Okay. Now, last piece of the puzzle. Is everyone with me, right? Okay. Last piece of the puzzle. Why don't you tell me the psi? Because the ball needs to go through the basket at a particular angle for it to go through it. So psi is, you see this one, this yellow line I have made, and then this fellow. This fellow is psi. So anyone who can at least tell me the strategy of cracking the psi?
We want to both two
Huh.
divide it with V naught and take the arc.
Yeah. Yes. His answer is that we find the VFX and VFY and you find the psi. So let me just write it down. Excuse me for you. VFX. I hope you don't lose the internet connection. You know, yesterday it happened like 4 times with me. So that's why I keep on saving this. VFX is equal to VIX, V naught X. You take the shots for naming your symbols, equal to V naught cosine 50, right? And VFY equal to, this one you have to tell me. So I will just go back, and if you want to take a picture of this one, I did write VFY somewhere here. VFY, where did I write it, by the way? I think I write it here. You see, VFY or VF or V at any point in the y direction equal to the initial one plus y double dot multiplied by t. So I will wait for everyone to just be with me on this one. Done.
So,
Yeah, why not?
so the reason why the initial velocity is equal to the final velocity of the x
in the x,
because there is no acceleration in the
Be-
x direction.
because there is no friction, there is no wind, there is no resistance
It's probably one of the where acceleration is constant. That's what one of the
in the x direction. In the x direction.
With that, right?
We talked about it. If I throw it in the x direction, so there is no resistance that is it is subjected to in an ideal world. In the y, for sure, there is g. Oh, come on. Sorry for that. I need to switch off this. Okay, everyone. So I think everyone is with me. So why don't you give me the answer? We have VFY equal to. Did anyone do it? VIY plus AYT. I am intentionally writing a plus AY so that I can tell you that now I have to remove the plus and AY and I have to put a minus and a G. Are you following me? And then VFY comes out to be
32.7.
seems correct to me actually. You said 32.7? VFY. Yes, I think. Yes, I think it rings bells. Yes, 32.7. So VFY comes out to be VIY is V naught sine of 50 minus. It's very tempting to put a 9.81, but remember that this is British. 32.2 multiplied by T, which is a nice and beautiful 1.302. One of the students said that VFY comes out to be 32 point something, right? 32.7. I will just write down your value. Feet per second. Okay, give me the psi, please.
I'm sorry, William. Vinat wasn't that. We have like 19 side is 32.7.
Okay, psi is 30. No, psi I think is different. No? Okay, I will give you have to give me one. VFY is minus 19. You are right. And I'm wrong. VFY is minus 19. Thank you. Why did I put a negative? Because I'm taking the downward as negative. Okay, and V and psi is tan inverse. I really need to switch here. Psi equal to tan inverse. Okay, you can do it with me. This fellow will be X. This is my Y direction, right? So let me just do it step by step, please bear with me. Okay, so I have this as my VFX, this is my VFY. So it will be, oh, come on, like this one. So this psi will be tan inverse perpendicular over base, this VFY over VX. So it will be tan inverse VFY over VFX. And it is equal to 19 over 19.22, around 45, no? Do we have anyone who is completely lost in this problem somewhere? Yeah, V naught is 29.9.
So why did we divide
We divided with the 19.22 because there is a VFX. If you look at that triangle, we have a tan inverse. You can see tan inverse. This is the psi. Tan inverse VFY over VFX. Tan theta is equal to perpendicular over base. My perpendicular is a VFY and my base is a VFX. So that's why I divided the VFY with a VFX. This is my VFY. This is my VFX. You know, this is my psi. So tan theta equal to perpendicular over base. Got it? No? Yes?
Yeah.
Sure?
Yeah.
It's positive. Okay. Right. Okay. Okay, let me ask Baran if he has any comments. No?
Could we go past the question again?
Yeah, so I had a projectile motion problem. Somebody threw basketball from his or her hands. The basketball goes through this one. The range is 25 feet. His or her hands are here and the basket is here, and there is a 2.5 feet in the vertical, the distance. The question said that if the initial angle is 50 degree, then please find the final angle psi through which the ball goes through the basket, the time of the total flight, the V naught, that is the initial velocity which the person should throw the ball in order for the ball to comfortably cover 25 feet. So my strategy was, you have to first write all the equations. One equation that I wrote was delta y equal to VIT plus half AT square. Delta y is positive 2.5 feet. I put a positive 2.5. Half AT square, I put minus half GT square, because I always take minus G for y double dot, even in the formula sheet. This is my VIT, and you can see that I multiplied this with sine because the whole equation is in the y direction. So makes sense that I really put a V naught sine of angle. Then once I got this equation, I named it as 2. My first equation was the range equation, that if you look here, S equal to VIT plus half AT square, and the acceleration in the x direction is a 0. So beautiful, x equal to x dot t is sitting here. I wrote x equal to x dot t here. This is my x, that is my 25 feet. This is my Vx, velocity in the x direction. You can see a V naught cosine 50, and this is my time. Two equations, two unknowns. I cracked the time and the V naught from here. Once I wrote the time and the V naught, the last piece of the puzzle was to find the psi. For finding the psi, it will be tan of psi equal to perpendicular over base. My perpendicular is the VFY, and my base is the VFX. In order to find the VFX, life is good. VFX equal to VIX equal to V naught cosine 50. The VFY is equal to VF equal to VI plus 80. Instead of plus, I put minus G. So I got VFY equal to this whole chunk. VFX known, VFY known. I substituted in the formula 10. Okay, why don't everyone goes through this? Now, next topic quickly, because we have a chat. I got it. Thank you. Okay, why don't we start the next piece of the puzzle? We have 2D planar motion that all of us are doing. Okay, then I have 3 different topics. One is the Cartesian coordinates. Then I have second as the normal tangential coordinates. And the third is the polar coordinates, right? Okay, now few comments here. This problem that we did right now in the projectile, that is Cartesian coordinates. Now I really want to talk about the normal and tangential coordinates. And let me just open a few notes here. I think that will be helpful for me. So I have something like this, and I have an object that is going. Now you can see that this is the center of curvature, right? I will call it as rho. Now, what the whole point of the radius of curvature is that you can draw a circle. So the radius of this fellow is the radius of curvature. Now for normal tangential coordinate, I have the object that is traveling, let's say, in this direction. So please remember how I am drawing these arrows, right? So the first thing that you will do is you will draw the tangential unit vector in the same direction, tangential, as the direction of the motion. So this is my ET. Now my normal vector will be 90 degree to it, right? You have heard it, right? So it will be something like this. Now it will be towards the center of curvature. Right now you will find this information as very trivial. Oh yeah, I'm just telling you it is towards the center of curvature. But as the concepts keep on piling up, trust me, this is the part where you will get confused. Normal, you will always draw it towards the center of curvature. Trust me, you have to write it down. You will see the reason why am I emphasizing it enough. Now, second thing is, when you arrive, let's say somewhere here, I will play the same game. The tangential unit vector will be along the motion. and the normal will be towards the center of curvature. So I will draw E caret N like this. And just to be clear, this appears to me the center of curvature for this chunk. So you can even draw a nice and beautiful circle. Done. Now, if I have to finalize this discussion, let us talk about the velocity. So anyone who can tell us the velocity? It will be, yeah, exactly. It will be, yes, I think I understand your answer. It will be V multiplied by E caret T, right? So what about second component? Will I have any? No, right now I'm talking about velocity. Will I have a second component of velocity? T, it's moving in a circular path, right? The car or whatever. So will I have a second component of velocity? Okay, you're calling it radial, whatever. So will I have a, let's call it normal component for now. Will I have a normal component of velocity? Yes. How many say yes? Okay. If I have a normal component of velocity, this is what will happen. So I'm going in a circular path, right? So I will take a 90 degree and I will start moving towards the center. Which is not happening, right? As long as the car is going in on the road, it's not getting into the grassy field, right? If you say that the velocity will have a normal component, the car has to take a 90 degree or the car will somehow enter into the grassy field. So there is no normal component. Let me repeat for the online students, there is no normal component of velocity as long as the car is going through this circular road, as long as I am planning to get into the grassy field like this, which is definitely not a good idea. So remove this. Okay, this is an important part. We will keep on repeating this. Now I will use the word velocity is equal to. Everyone is clear about this? Why did I say the normal component is 0? Okay.
For example, in the first curvature, if the velocity of and
if there is an
the car must be goes towards the,
it will definitely leave the road, right?
Yeah.
Because the velocity is tangential to the path, the car will leave the road. It will get into the grassy path. Okay, now just finalize this by telling me what is the velocity V? This will be rho omega, r omega. Do you remember that from your physics classes? Your professors used to tell you that V equal to r omega. Does it ring any bells? So I am writing this as r omega. Now just to be, rho is the radius. Okay, again, okay, yes, let me write it down as radius. I, as well as your textbook, usually use this letter. So just be clear that rho is definitely not density here. Now you might be confused with the theta. So I think I need to tell you what theta is. So this is my theta. Because the radius of curvature also, what is the English for that? Traverses or moves, right? So it's the theta. Now, last but not least, why don't you help me with the acceleration? That's the interesting part. Yeah, r omega square is the right word, but let's go step by step. One will be the fact that the car is traveling like this, right? I see the speedometer. The speedometer tells me that I'm putting the foot on the pedal. I'm accelerating, so I will put a V naught, right? In the tangential direction. And what about the normal direction? You said r omega square. Somebody said r omega square from here. So I will take that answer as V square over R. And I will write it like the physics one, E caret T plus V equal to R square omega square. And I will have, what was that? R omega square you told me, right? R omega square E caret N. Okay. Is this clear or not? I am really, I think I need to repeat this so that everyone is with me. So I will again repeat that I have a normal acceleration as an equal to V square over rho. V is rho theta dot or r omega from your physics one. Then I have rho square theta dot square divided by rho. Then an equal to r omega square, as one of the students told me. And theta dot can be written as omega. Okay. Is it clear? Right, everyone? I am speeding through it, thinking that you have gone through this in physics 1. Got it? So acceleration has 2 components. Velocity has only 1 component. Should we do a problem? Yes, no? Okay, if I were you, I will just memorize this, that the velocity, okay, in the tangential direction, I have along the path or tangential direction, whatever, I have a nice and beautiful v dot. In the normal, I have r omega square or v square over r. And for the tangential, for the velocity, there is just 1 component. Okay, we have a countdown now, 10, 9, 8, 7, 4, 3, 2, 1. So do this problem yourself. You are definitely doing it. I'm not doing it. I have a horizontal path like this. The reason I'm telling you horizontal path, I don't want you to think that something is flying like this. It's like a horizontal path. The car is traveling like this, nice and beautiful. The velocity is 60 miles per hour. You have to Google it, by the way, miles per hour to feet per second. I have no idea. That's 60 miles per hour. Okay. And the question says, if the radius of curvature is 2,500 feet, then find if V is constant, if, hang on. Second case is if V dot is 2.75 feet per second. And the third case is, we will have a break after this. V dot is equal to negative 2.7 feet per second. Oh, what did I write? V dot. I think feet per second square, no? I think the units are wrong. The question says you have to give me acceleration for the 3 cases. And can somebody tell me 60 miles per hour, 2 feet per second directly? Final answer? 88 feet per second. Okay. Okay. Okay, do it. Should I draw some diagrams? I don't think so. Everything is known to you. You give me the acceleration for case 1. Tell me how are you approaching the problem. So it's a horizontal path, okay? It's a car. It's not some rocket that is going in here. This is 2D. A horizontal path. Yes. These are different questions.
Different questions. Okay. So is this
This is case 2. You for now can tackle case 1.
Okay.
So case 1, finalize case 1, tell me the answer, then we will go to case 2, then case 2. This is tangential acceleration in case 2.
2 and 3.
And case 3 tangential acceleration. I just want to double check if I missed anything. The question is complete, right? Yeah, the question is complete. It's a circular path. So anyone who found it, they can give me the answer. Okay. So this is my case 1, 88 feet per second, like this, tangential, right? Tangential 88. So it is A equal to V dot E caret plus, what was that? AN, which is V square over rho E caret. What is V dot? I think 0. No, for case 1, 0 E caret T plus V square over rho is 88 square over 2500 E caret N. I think someone said 3, something 3, right? 3.1, huh? 3.1 seems to me correct. Now, just one quick remark. What is this velocity? Tangential, right? So just remember this. You are substituting tangential velocity in the normal acceleration part because there is no normal velocity. Okay, what about case 2? You definitely have to do it. What is this E caret? E caret is a unit vector. E caret is a unit vector. Unit vector. Remember that little view that you used to use in physics? IJK is in Cartesian coordinates. But if I have to use this same kind of unit vector in a tangential and normal, I just use E caret T. Instead of E caret T, you can come up with any symbol. E caret and N caret. So IJK is like this for me, E caret and N. Everything's fine, right? 5.96. But did you just add them together? Don't add them. So for example, put E caret T and put E caret N. E caret N, and don't add them and do a square of this plus square of this plus square. They're basically the magnitude is the same. Sign in the E caret T part of the it's straightforward. I think everyone understands this, so I will. What happened? Something happened with the pad. Okay, let me finalize this and let's start something new. So I have V A vector equal to V dot is positive 2.75 E caret T plus what is this one? 88 square plus somebody said 3.10, right? E caret N. And for case 3, I will have negative. So the driver put brake negative 2.75. He or she put brake plus 3.10. Oh, did I do E caret N? E caret N. Now, just quick remarks. Let us draw nice and beautiful drawings for the 3 cases. So for my first case, I am getting this one. This is my case 1. Done. Okay. For my case 2, let me do quickly. This is my case 2. Right. This is my case 2. Let me use a yellow marker. So I have E caret T 2.75 tangential. I will make the normal vector a little bigger than this one. No, right? Control Z. Oh, come on. Okay. So I will just join them together. So I think accelerating in a circular path is definitely not the smartest of things that you really want to do in your life. You can see the acceleration is like this. If the traction by the tires is not big enough, your car is definitely going to slip away. So this is my A for case 2. No, it's simple A for case 2. What about case 3? No, this horizontal vector will be flipped. No. So it will be, this is my case 3. I'm just squeezing everything on the same slide. Let me finish this. This will be my AT. The driver has put brake right. And at the same time, you have normal a little larger than 2.75. Then my resultant vector will be like this. Again, if your traction of tires is not big enough, for sure your car is gonna skid away if the traction of tires is not big enough. A, T, no, not AT, simple A. Okay, everyone. Do we have anyone who is not sure of this one? The next one. Okay, we are at 11:18. Yes.
When we draw in a circular line,
Okay.
the car wants to go away from the center of the circle. In our drawings, the car wants to go to the center of the circle.
Oh, look, I understand that's the centripetal force equal to centrifugal force of a discussion. So the answer to your question is that the moment you I think I understand. So what is the explanation for this? The FC is your mv square over rho, and your centrifugal, I think I understand your comment actually. So centrifugal force will be again mv square over r. Your comment is correct, because that's why there is a little banking that we put on the roads, so that there is a banking so the car does not skid away. His question is, then why we have a vector towards the center? That is actually a
Because of friction, right?
Yes.
no, that's not the answer to his question actually. Your question is good. Okay, I will think about it, but it's a valid question, because when we put banking on the side of the road, so the car, you have little banking in the road many times, right? So the car does not skid away. This question is, then why A is like this?
That backing is to support the friction. That the weight of the car adds to the centrifugal force.
Yeah, that's correct. But his question is that why I have a vector towards the center? Won't it be something different to what we always observe, that there is actually a banking so that the car does not skid away? His question is, this is automatically towards the center. There has to be a very simple answer to huh.
In this graphs,
Huh.
you're looking to the upper part.
Yeah, so yeah, this is the horizontal and I'm looking from here.
Now, so therefore, John, if we don't have any friction in tires and road,
Huh.
we couldn't do this circular path.
Huh.
But if there is a friction, because of that, there is a force. If there's a force, it must be an acceleration. And therefore, the acceleration must towards the center.
My answer to this question is that even when we move the bucket very quickly, right, just so that it hangs in there, very quickly if you do that. So the whole point of putting it in a huge velocity is so that the bucket hangs in there and there is a normal acceleration towards. That's the possible explanation right now I can come up with. But I will think about it, because I understand your question. I will think about it. Because we put banking, so I think he has a valid question, by the way. Okay, we will get back to this again. I need to, but let me make another problem. So I don't think we want a break, right? Something tells me nobody wants a break. Do we want a break? Really? Let's have a short break. So it's 11:22. Please be at 11:25. let's. Okay, yeah, 27. I wanted to say 27, not 20, not 25. 27. Okay. Accelerating. Okay, let me just make then a drawing for you and we can start again. This is a conveyor belt, nice and beautiful. ठीक हो गया. Then we have T. This is ये PNG और ये आपका. Okay, then we have come on. Then we have 3 meter. 3 meter. And this is 2 meter. That's fantastic. Then we have V dot equal to 0.2 t, and we have meter per second square. This is again a horizontal plane. We have to find the AB. That's a good question. This is a horizontal conveyor belt. So you don't think that it's flying horizontal conveyor belt. That's a nice dynamics question. Horizontal conveyor belt. Find AB. And
Should we use the book from the Hiblers or the Merriam?
you should use Hibbler. Hibbler is our textbook and it's a fantastic book. So the way I am proceeding, I actually am, if you even look at open the Hibbler, the way I'm moving, I'm following Hibbler. But if you are really interested in practice problems, I would suggest that you go over the whatever. So for example, normal tangential, you can open the Hibbler book, copy paste. This is what I am covering. You read the Hibbler, then you do its examples. And if you're looking for more examples, my suggestion is open the Merriam, because Merriam's examples are more advanced than the Hibbler. So for the same topic, I think this conveyor, I think it is in the Hibbler book already. So it's more like I am already covering this example. You really want more practice, then open Merriam as well.
Okay.
But I am following Hibbler. And you can you have access to both the books, right? Good. 11:27. Did I decide or 29? 27, right? Okay, 27. Okay, everyone, I think we can start. So the block arrives here. This is my block. Nice and beautiful. The package arrives here. Okay. Okay, so, I will start the question. V equal to, what was the formula? V E caret T and A equal to, okay. Yes, right? Okay. And what was that? V dot. I keep on using the word horizontal conveyor belt because I don't want you to think that it's falling from the air. So it's horizontal, it's like moving like this. It is V dot E caret T plus V square over rho E caret N. Okay, any suggestions? How should we even do this problem? I think V dot is given to us 0.2 t. So at t equal to 0, the velocity, the acceleration is 0. So acceleration, so this is definitely not a Vf equal to Vi plus At problem. No, this is not S equal to Vi t plus half At square problem. No, this is definitely not that 2as equal to Vf square minus Vi square. In any case, this is normal tangential, but not at any point will you be able to use those three formulas anyways, because this is not constant acceleration. This is a variable acceleration, 0.2 t. Okay, any suggestions, anyone else?
So that's the end of the straight line.
Yeah.
And then
Yeah. Yes, you are right. So yes, that is the approach. I will actually, his answer is that find the velocity at B and you will be able to crack this part. Correct. So let's say A equal to V dot E caret T. The V dot is 0.2 T E caret T plus V square over rho E caret N. This is definitely going to be a little tricky. So I will say I need to find ATB equal to first question mark. That will be at T subscript B. And in order to do that, how can I even find it? Because you have to understand, your answer is correct that you have to find the velocity, but the point is that you also have to find the V dot, that is AT, because you don't even know the time it takes the package to arrive here. If I know the time TB, then I will substitute here and I will get the AT. You get my point? So there are two parts. You have to crack the acceleration in the tangential here and the acceleration in the normal here. You even don't know AT because AT means V dot. V dot means 0.2 T. T means TB. So I don't know TB. So there are multiple layers to the problem. So I will write V dot equal to 0.2 T. Then I will write that this is equal to dV by dt. And then I will write that it is, this is a tricky problem by the way, everyone, 0.2 T dt. And then I will say that I have to crack somehow the velocity. So you will go do a 0 to V B, and then you will do an integral of 0 to TB, no TB, because B is something that I'm focusing on. And then you have, then that's the end of it actually. You cannot even proceed from here because you don't know t. So that's the end. So any suggestions?
We can put S.
Yeah. Yes. S. That's the right answer. If you crack somehow, because you know the S, right? At the end of the day, this is 3 meter, and this circular path has a radius of 2 meter. So somehow you will be able to find the distance t as it moves. So you are right. I will do a ds by dt equal to v. That is the right answer. And I will do a ds equal to v function of t dt integral 0 to tb, right? Tb. Okay, that's good. Now again we are stuck. Now what? Do I have v? I have v. Yeah, I think I have v from here. I will substitute here, and I think we can solve this. So let's now do it together by tackling this part. So I will have an integral of dv is vb minus 0 equal to what is that? 0.2 t square over 2. Yes, no, 0.2 t square over 2. Okay, I'm skipping some steps. It will be 0.2 t square over 2. You have to put a bar, then you put tb, then you put 0. So now that I have vb equal to 0.2 over 2 is, I think, 0.1. No. So vb is 0.1 tb square. Okay. Now I will take vb as 0.1 t square, or probably I think instead of b, just to make my life easy, let us even remove the b for now. I think it's completely not needed right now at such an early stage too. So I will just do a v minus 0 just to make my life easy. Now I will decide whether I really want to find at b or a or b or c, whatever. So now v equal to 0.1 t square. Now I will substitute here. I don't want to leave the slide, so I will keep on squeezing everything. So integral 0 to SB will give me, yes, thank you. It will be SB minus 0 equal to integral V. So it will be integral 0.1 t square dt with a 0 to TB. Then I have SB equal to, someone who can do the integration. What is that? 0.1? 0.1 over 3 t power 3. Then I have a 0 to TB. Oh, come on, I'm not going to do that. I will just do a TB. Okay, done. Okay, what is SB? This problem is not ending. What is SB? No, SB, no. Let me tell you what do I even mean by SB. Like this. This. Huh? The whole thing. Give me the whole thing. So did I tell you the distance? I think this distance I told you 3. This distance is 2. So what will be this distance?
3 plus 5.
3 plus 5?
Pi.
Pi. Yes, pi. So his answer is that do a 2 pi r. His answer is do a 2 pi r. So that will be a circle. This is 1/4 of circle. So his response is divided with a 4. So in fact, I will just do it for you. 2 pi r divided by 4. And I will make it here. Are you getting my point? Done. So I will just write the answer. SB is 3 plus 2 pi r over 4 will be 2 pi into 2 over 4. So it will be pi, as one of the students mentioned, 0.1 over 3. Let me use a different color. 0.1 over 3. Okay, and then I will write a TB power 3. Okay, finish the question from here. I'm not doing it any further. Whatever is left, just do it. Okay, I think from Hebler, we can also do examples from many. Just give me the final answer.
5.69.
You got it already?
3.24.
That's good. Everyone got it. Okay. Okay, so one of the students said time comes out to be. So give me the accelerations. Yeah, because that's the final question, no? Okay. Time, you said 5.7? I think 5.7 is the right answer. So time, one of the students said is 5.7. I will just note it down here. Time, he's right, I think. 5.7. You mean the tangential or normal? No, give me the tangential acceleration.
2.2.
No, tangential acceleration is 1.14. Okay, what about VB? Can we even see that? Okay, 0.1 t square. So VB is 3.24. Okay, meter per second or feet per? I think it's meter. Meter. Okay. Now tell me the AN. That will be a VB square because this is at B over rho. So, 5.25. Okay, I don't have the answer. 5.25. I will take the answer. Huh, 5.24. I have in the book or in the notes. Okay, 5.24 or 5.25, whatever. Probably I'm wrong. Okay, what about 80? That is, where is the 0.2 into t. So 0.2 into t, I think you told me 5.7.
0.2 into t will be 1.13.
This is correct. 1.14 I have in the notes. Done. Meter per second square, nahi? And this will be meter per second square. I think the problem is over, no? That was the problem. Now, just as a last remark, where will be the normal acceleration directed to? It will be directed towards this fellow. Now, let me use a yellow marker. Let me save these because internet can disconnect it. Okay, this fellow. Okay, what about tangential acceleration? It will be directed because it's going like it keeps on, the acceleration keeps on increasing, right? So it's a positive acceleration problem. So I will put the value of ATB is less than AN. So I will make sure that this arrow is less than that arrow. And I will have a nice and beautiful arrow in this direction. Boom. Life is good. Okay, everyone. So I think this is the right. Oh, what happened? So just let's write down the final answer as A equal to, what was my ATB? It was 1.14 meter per second square caret, E caret, plus, what was that? 5.24 meter per second square, E caret N. This is my, and with a subscript B. This is my acceleration at the location B. Nice and easy. Is it fine? Straightforward. I had to find acceleration at point B. There are two components, tangential, normal. Should I repeat? Should I go over it? Any comments? Yes, no? Does Baran have any questions for us? Where is Baran? Oh, he is with us, yes. Okay, I think there are no more questions. Nobody is asking. Okay, so I will just make a problem. You do it yourself. This time, definitely you are doing it yourself. So we have, this is definitely looks like a rocket. I'm emphasizing it so you know that this is not a horizontal motion. I mean, horizontal. I mean, it's not like in this plane. So, okay. This is my tangential. It's 400 feet per second. And I have 70 feet per second square of acceleration in this direction. Okay, this is 70 feet per second. Did I say acceleration? Sorry, 70 feet per second square. So I am giving you two components. One is the tangential component, and one I am giving you the acceleration. And this angle is 60 degree. The question says, find the rate of increase of speed Okay, let's see who can do it. Find the rate of increase of speed. Give me v dot. By the way, what is v dot? Acceleration in which direction? Tangential. Yes, v dot. Thank you. And give me the radius of curvature of the path. That is rho. And I will make one diagram for you just to make your life easy. Of course, in an exam, you will do this yourself, but I'm doing it here. So this is my E caret T. So, okay, I want to answer your question. You said why E caret? What was that? Yeah, E caret. So instead of E caret, if you don't want that, you can put a T here. Right? You can put a T here if you want, like this. And then you can put a N here. But I don't know, I just don't like this T and N. I want E caret T here. Okay, let's put a T here. I think you're right. Sometimes we can put like this. And this is N or E caret N. And this is my 90 degree. And this is my acceleration. So please focus here. Look at the horizontal acceleration. Somebody has given me that the acceleration, interestingly, is horizontal. 70 feet per second square. And this angle is 60 degree. And somebody told me, oh, this one is 400 feet per second. Okay. So at least tell me the thought process. What are you thinking if you cannot do it? By rating access being normal. Normal. Just keep using the word normal because in the next topic in polar coordinates it will be using the word radial. Although it's fine. Okay, you find the normal and the tangential as well. You have to find both of them till 400. So that is velocity. That is the acceleration.
Acceleration was 32.2, right?
I understand your question, but I don't think you will be using that here. I will tell you why. Meaning, I will tell you why won't you be using that? How should I explain that? Yes, I will answer this question first. Actually, the object is accelerating at 70 feet per second square in the horizontal direction. So definitely appears to me, it can appear to me as a powered flight.
So there is no other acceleration.
So because, look, I will tell you, the force that is being generated in this powered flight is taking care of all the other forces and everything. And at the end of the day, the object in a horizontal direction in a powered flight is going through 70 feet per second square of. Are you getting my point? So everyone, please don't include any 32.2 here, okay? You have a 70. Yes.
Therefore,
Uh,
it's normal acceleration just causing that the velocity's direction changes, right? It's so.
no, I don't know.
I'm trying to say that we are at velocity equals tangential velocity.
That's it.
That's it, right?
Ah.
The
Uh,
acceleration
in the normal.
situation,
Ah.
normal, just causing, for example, the velocity goes like this, or in some way goes like this, goes like this. Acceleration causing changing the velocity's direction, right? The normal acceleration.
You can put it like, because the object is going in a circular path, that's why the normal acceleration exists. If you want to use the word vice versa, then that's fine with me. But here, the problem is pretty straightforward. You know why? Because the final acceleration has been given to you. Because 70 is already given to you. I am asking you, now you have the answer, just give me the tangential and normal acceleration.
That 70 is actually the main acceleration.
It's the main, it's the
So
final
to get the
thing.
normal, we could divide it by 2 constant time.
Yes,
Right.
70 can be divided into its projection.
So that's normal, it's gonna be sine.
Exactly. That's the trick actually, because now I have given you what the tangential scale plus normal scale square root is equal to. Yes. Okay, now I need to see the notes. You said 395 for which one? For radius of curvature? 35. Who said 35? 35 is the, I will do a AT equal to A cos 60, which is equal to 35 feet per second square. So this problem is flipped from the previous problem. AN equal to what was that, 70? So I think the projection will be like this. Sorry, like this angle, right? So 70 cos 30, or let me make it easy for me, 70 sin 60 if it's fine, right? Everyone understands this, right? So I have no idea. 60.6 appears to me correct. Okay, now you are definitely giving me the radius of curvature. 2640 appears to me the right answer. Thank you. So it is equal to, what was the velocity, by the way? Do I even know it? 400. So 400 square over rho equal to 60.6 feet per second square. Here I will put, come on, meter per, why I'm using feet per meter? Okay, sorry. Feet per second here with a little square. So rho comes out to be 2460, as one of the students said. Sorry, 2640. Okay. Okay, what about V dot? I need to see the V dot now. V dot is? V dot is 80. So let me encircle the answers. V dot is your 80. Okay, the radius of curvature is infinite. What does that mean? If radius of curvature is infinite, it's straight line, right? So I'm going in a straight path. That's my radius of curvature right now is infinite. If I go in this small circle, the radius of curvature is very small. If I take the circle of this classroom, my radius of curvature is definitely a little big. Okay. Do you want to do one more problem probably? Just so that. This is okay. This one is projectile. Do we have any questions? Any comments? No? Yes? No questions? Okay. This problem I'm about to do, your first remark will be, why on earth are we even doing like this? We know the projectile motion, but I'm intentionally making this. You will still do it by normal tangential, okay? So I have. What is the question? Do you have any questions? Sure? Positive? Okay. So let me make this from a helicopter or whatever. Somebody's throwing these packets. I have this distance as 1500 feet. So I'm asking you to do it by normal tangential, okay? This is my 1500 feet. This is 150 feet per second. One fifty or 50, I am not even sure, but I will take it as a 150. Okay, the question says that the packet arrives here like this. It goes like T, it goes like this. The packet arrives like this. At this point, you have this velocity, tangential. This is my VB. This is my A. This is my B. This is B. Okay. So how many have still classes today in the day? You still have classes after my class?
Yes.
Oh, so the weekend does not start immediately. Let me put it like this. Let me put it like this. This is our VB, nice and beautiful. Okay, let me come up with a question. Find AB and rho B. By which method? By which method? Go back. What were the three ways? Cartesian coordinates, normal tangential, or polar? I'm not asking you to go with the Cartesian. I'm not talking about, I really don't want you to tackle it with a projectile motion way, although you can do. Focus with the normal tangential because that's the topic right now. Because I still remember one of the students did point out that it's so straightforward with projectile. Why are you even asking us to do it? Okay, anyone who wants to tell us? You are definitely doing it yourself. I will make some diagrams, otherwise it is impossible to start like this. So this is my horizontal line, let's say. My normal appears to me like this. How many agree? Because if this is my tangential, then my normal should appear at a 90 degree. Right? And my tangential acceleration will be in which direction? Along the VB or not? Okay. Can you just tell me whether the tangential acceleration will be along velocity or not?
Yes.
Of course. So tangential is along the V, of course. It's tangential. My V is also tangent. So I will make a nice and beautiful arrow for my AT. Done. Let me put a B and a B here. The yellow color is barely visible, by the way. Okay, let me now talk about G. My G will be this fellow. Okay. Okay, just one question and then we will proceed. If I just ask you, the question says find AB. That's really funny, by the way. What is the acceleration at point B, by the way? That's super funny the way we have formed. What is the acceleration at point B? This is just simple G. So that's why the question is also kind of funny. The final acceleration, the acceleration at point B is G. Okay, so it's just remarkable how the problem has to be formulated. But anyways, if I ask you find AB, it's G.
Why is it not B square over R?
I will tell you why. I will tell you why. That's a good question. That is just a component of it. So I'm now answering your question. So this looks to me like a 90. This is the G, as one of the students said. And this is second component. Okay. Okay, now I am answering your question. Your question was why the acceleration is not normal, right? Okay. Look, G has two components. One component is normal and one component is tangential. Are you getting my point? What happened? What is your question? One of the students said something.
I said the component cannot be greater than G.
Of course. So I have a theta that I have to make, which is this. Okay, and so I think, why don't you give me find AT and AN? I think that's better question than the one I have formulated. You're definitely doing it now. Think about it, use your imagination. No, why did I name it as a theta, by the way? Theta, I think theta, why theta? No, don't name it as theta. I think let's call it beta, because theta in projectile, you remember. So, and I will just make sure to color it smoothly. And this is ATB.
So in projectile, do we have a row?
Look. The object is definitely going in this path, right? So technically it has a circular curvature to it. So that's why what we are saying is, instead of going through your projectile, why don't you tackle this as an object that is following a circular path? So definitely at any particular path, if you see there is a radius of curvature. Radius of curvature itself also can change. We saw that, right? Car is going in this fashion. It keeps on taking sharp turns and then it keeps on taking big turns. So the radius of curvature is different. The radius of curvature here is different. This object itself has a circular path to it. Now you can argue with me what is the radius of curvature there and what is there. I'm not talking about that. I'm saying right at this point, find it. So at this point, if you find the normal acceleration, you will give me the radius of curvature. So why don't you do it, everyone? No? Yes, no. My suggestion is, why don't you write A vector equal to AB vector equal to you can write it like V dot E caret T plus V square over rho E caret N. Now you really want to put some subscripts. Okay, B you already said so. This B will be your BB. We put BB here.
Isn't the radius 1500?
Oh, you see, I'm happy you brought this up. No. Let me see the answer. No, not possible. So, did I ask you the radius of curvature?
Yeah. Let's give it section 5.
No. I have already told you the answer. That's no. I'm talking about point B. Let me also see the answer. That is my point. Look, I am asking you to find the radius of curvature at this point. The radius of curvature during a path can also change. Because even if the car is traveling, the car takes a sharp turn, then car takes a big turn. So the radius of curvature will be at every point. It can change. That's why I said, give me the normal acceleration at B and give me the radius of curvature at B. In fact, please see this. I said rho B. I did not say radius of curvature at any other point. No? Yes? Do we have anyone who? Okay, that's again physics one, by the way. Okay, I will definitely help you in this one probably. Should I start or not? G value is 32.2, please. Not 9.81 here. Okay, I will definitely start this problem, otherwise it will become confusing. So I think my first step will be A, B will be equal to A tangential B plus A normal B. Then I will write a V dot B E caret T. I will remove the arrow A and V square over rho E caret N. Then in order to find VB, I will say it is equal to, what was that formula? VF square minus VI square equal to 2AS, right? 2AS. Yes, no. Everyone agrees with me in this one? No? Okay, V by Y. And in this way, I will get a VBY square equal to, what is VAY?
100.
No, VA, 0, right? 0 plus 2, what is AY? Minus 32.2 seems to me the right answer. Feet per second square. Okay, what is delta Y? Okay, before I know you are thinking, why on earth are you even doing it? My strategy is I will crack this VBY, then I will crack the VBX. That will give me the VB. Once I have VB, I will get V square over rho ABN. Are you following me? That once I have ABT, right now I'm not sure to think about it. In fact, one of you can even tell me how would you find ABT? Or we can think about it after a few minutes. Let's focus on ABN. Okay, what about your delta Y? 100, no, it's 1500. Minus, right? Minus or plus? Minus, because your delta Y, it's in the downward. So my minus 1500. Minus 1500 feet. Okay, give me VBY. I don't have answer. Quickly. 310.8. Somebody said that. 310.8 probably is the right answer. Yes, 311, right? 311 feet per second. Okay, why don't you tell me VBX? Okay, you are definitely going to do it. VBX. VBX. So velocity at point B in the x direction.
100.
100. Okay. Because this is unpowered projectile. I'm sorry, projectile motion. So one of the students said, just write 150 because VAX and VBX in the x direction you don't have any acceleration. Okay. So what about? Give me the final velocity then. 345. Come on, what is the answer? I don't have the answers with me. Okay, I will take the answer. It is square root of 150 square plus 311. You said 345? 345.3. Okay, I will just write down the answer. We will see if I'm right or wrong. Done? Okay. Okay, what was the question? Let's get back to the question. We have to find ABT and ABN. Now you tell me how can we proceed because it has become tricky now. What should we do?
We can find the angle and then we can find the vector.
That is the right answer. 100%. Crack the angle and the rest is over. Thank you. That was just the right answer. So just as he mentioned, why don't we find the beta and finish the problem? So beta equal to, let's do a, does it even look like a 90? It's just a horrible job. So tan beta equal to perpendicular over base. So tan theta equal to, how can we find beta?
We can find the angle between velocity and the ground, and then we can deduct that angle from 90 degrees to get theta. Because the acceleration vector makes a 90-degree angle with the ground.
I think you're right. In fact, there is one more way. Yes, you're right. Let's do this as a Vy, right? Because Vy is in any case in this direction, and this vector is a Vb, as you already know, and this vector will be my Vx. So let me make sure that I'm Vbx. So this, I think it does not look so. Let me draw another arrow so all of us are on the same page. So nobody says that why the vectors doesn't look correct. Oh, come on. I think now it looks correct. This is my VB. Now I have to change my VBX. I will just make it, oh, come on. I will make it little lengthy, no? Oh, come on. So I have, this is VBX, correct? So this is my projection. This is my Vy is also like this, somewhere here. Okay, so done. I will do a beta equal to tan inverse okay. Tan inverse tan theta. Okay, it will be perpendicular.
Why VB1? Right?
A VBY over VBX.
No, yeah.
VBX over VBY, right? Okay, so we will do a tan inverse because it is VBX. Let me write it down, otherwise it's hard for me. This is my VBY and this is my tan. So it is perpendicular over base, VBX over VBY. I think so. VBX over VBY. Okay, give me a beta, please.
25.74. 75.
25.75.
25.75.
I need to see some answers on my notes because you said 25.74, right?
75. which I mentioned.
25.8 is in my notes, so I think it's correct.
Okay.
Done. Oh, come on, that was one weird question. Now let's do a ABT. It will be. Now you are definitely telling me. So it has, one of the students said that in order to find ABT, it is G cosine beta. I will take that answer. And ABN will be G. What was that? Sine. This is the yellow vector will be in this direction, so it will be sine 25.8. Okay, give me the values, please. Look, you have to know what you are trying to do. Otherwise, all of these are just crazy steps that we are doing. Our method was that G is the acceleration at point B. I want to crack ABT and ABN. I need to get the angles that the normal and the tangential will have so that I can do the projections of G. I knew it that the way the velocity is behaving, the tangential acceleration will be on the, let me do it for the recording. The tangential acceleration will have the same arrow as will have the arrow in the same line as VB. So first I found VB, the angle it is making with the vertical line. So I knew my ABT will be sitting on the line of VB. Then I will do a G cosine to crack ABT, and then I will crack G sine of the beta.
For example, for the ABT, it's 28.9.
28.9. 28.9 or 99, whatever. And G sine, I will use a different color.
.01.
Do they square up to 32.2, by the way? If they don't, then we have a mistake. Are you sure that 28.99 square plus 14 square root of 2 gives me 32.2? Done? Oh, good. Thank goodness. Otherwise, there was a mistake. Do we have anyone who is not sure what we did? It was one lengthy problem, no? Yes.
When whatever the package hit the ground, it's no longer moving. So it no longer has an acceleration.
Oh, no. So always remember that if I ask you, give me the acceleration as it hits the ground, it's more like just momentarily before it hits the ground. It's always, it is always that approach. No? Like, give me the acceleration before it hits the ground means right at that moment. That's the whole point of the impact, because it has an acceleration, there is an impact subsequent to the, so right at that moment. Okay. Let me just double check we have a mistake or not. So you can just see the arrows. One arrow is like this, 90 degree to this yellow arrow. The G has two components, green arrow, yellow arrow, green arrow, and yellow arrow. Then I have this big is the VBX. Okay, the green and blue overlap. This little blue actually starts from here. I don't want you to get confused. I will start it from here. And then this brown arrow has two components, the blue one and this blue one. So green has two components, the yellows. This brown arrow has two components, this blue and this blue. Okay, everyone. I think life is good right now.
Also, we need to find the row.
Oh, really? Oh, the problem is not over. Okay, find the row then. Oh, problem doesn't seem to end. Normal acceleration, what was that now? Normal acceleration was 14. Okay, let's do a red. 14 0.01 feet per second square, then what will be the velocity? The VB, right? Because velocity you take as the tangential divided by rho. Give me the rho, please. Come on. It is. But by the way, I have something north of 8,000 in my notes.
Hocam,
8,500. Thank God. No? V square is there. You have to take a square root. So
hocam, it says that
feet. Okay. What about VB that you are taking? Can you just show me where did I write that?
Left corner. Left corner.
Left corner. This one. This one. Thank you. 345.3. Okay. Thank you for pointing it out. So I will put a 345.3 square. Okay. Something tells me that this is the, we still have 10 minutes, which is pretty remarkable. Okay. Any questions for me, by the way? You have to just give me a few minutes before I tell you to that the class is over. Let me think if I.
Can you show the VP square equals to VY plus 2A delta Y?
Yeah, this one.
Yeah.
So my strategy was to crack VB. In order to crack VB, I wanted VBX and VBY. In order for VBX, life is good. There is no acceleration in the horizontal or X direction because it's an unpowered flight. It was VBY that I really wanted to focus on. For VBX was 150, right? All the way. VIX or VFX 150. For VBY, I wrote this formula. So VBY square 2AS is equal to VF square minus VI square. Everything is in the Y direction. So instead of S, I substituted a delta Y. Instead of A, I substituted AY. Instead of, you get my point. So now VFY is my unknown. It is equal to, what is VIY? It is 0 because the object started its trajectory from horizontal. I substituted minus 32.2 because whenever I put acceleration in my equations, that's what I have taught you. I put a minus G. Instead of delta Y, I substituted minus 1500 because it's going down. I cracked VBY. I knew VBX. So one of the students did a 311 square plus 150 square root for me. And I got this. Okay. Okay. Just give me 1 second, please. Should I tell you something right from my head now? Now the internet is also not working. Okay, any questions from homework? Any comments? Oh, come on, internet. When you need the internet, it's not there. Okay, since internet is not working, just one quick remark and right from something that I just want to share with you. Next time around, okay, next time around, I will talk like this, something that you can think about forever, like till now in your classes. This is what you have been studying. You have a rigid rod and they used to tell you that this is a bob. Then they used to tell you this is the angle, right? This is small mass. What we will be talking about is that polar coordinate systems. Again, from my head, I'm just telling you. We have 4 formulas, 1, 2, 3, 4. I just want you to remember them. VR equal to R dot. V theta is equal to R theta dot. AR is equal to R double dot minus R theta dot square. Internet is not working. This is just funny. R theta double dot plus 2R dot theta dot. Something to think about this weekend. In fact, you just tell me if this thing is rotating. Trust me, we are actually moving to some real interesting dynamics. This time around, so this is a rigid rod, okay? Now I am making another system. Think of an elastic band, and on that elastic band, I put this mass again. Are you following me? Okay. So both of their motions are entirely different. In fact, you can YouTube this as well. You will see that this motion is just crazy. You know, the bob is going like 10, 10, 10. It's also going like 10, 10, 10 in this direction. Now, and you have to understand that if I ask you, give me the velocity of this bob. So focus on case A and then case B. So anyone who wants to talk about case A, what is the velocity of this one? Case A, V of this bob, of course, because this is massless. I don't care about this. And this dimension is R or L, whatever. What is the velocity? R omega. Okay. R omega or L omega. Correct? Done? Okay, good. Tell me the direction of this velocity. You mean like this?
Yeah.
Okay, good. So I will say that this direction is V theta. Done. So I will put a subscript. So far, so good? Okay, good. Okay, why don't you tell me what is the velocity VR for case A? Who said 0? Yes, 0. Why? Because it's a rigid rod. Excellent answer. VR 0. I think everyone is picking quickly. Okay, why don't you talk about case B now for me? What is V theta? Because now remember, this is doing like 10, 10, 10 as well, and then going 10, 10 as well. So tell me V theta. R, okay, R. Let me put this dimension as L or whatever, R. So I will say L theta dot. Okay, good. What about VR? VR is what? No. It's a spring, but you are getting into the kinetics, the force of the spring. No. It's kinematics. How it's behaving like this, it's not my concern. You just tell me the radial velocity. Good. No. So just this. So it is L dot R dot whatever. L is not constant in the case B, right? So even if you don't like the fact that I'm putting L and want to put R dot, that's fine. But it is crystal clear that the length is changing. Okay, before I say goodbye to you, why don't you just help me with the A theta for case A? A theta. Now, this is super confusing. Looks super confusing, right? Do you remember? Okay. Tell me A theta for now.
L theta double dot.
L theta double dot, then
L dot theta dot.
plus this one, na? Plus 2 R. Oh, but do I have L dot?
No.
I don't have 2 L dot. So I will just do a 0 into theta. So it's a 0. 2 multiplied by 0 multiplied by theta dot. Okay, what about AR? AR is, no. You look here and go step by step. So what about R double dot? My length is not changing. 0. What about this term? Oh, wow. There is a term minus. What is this R? L. What is this? Theta dot square. Okay. So this means A theta is L theta double dot and AR is minus L theta dot square. Just quick question before I say goodbye to you. Does this answer make sense or not? It does, right? Because I have tangential acceleration in this direction. What was that formula from your physics one? R alpha. R alpha. R alpha. Do you remember R alpha? Is this R? Yes. Is this alpha? Yes. Okay. What about this term? Do you recognize from physics one?
R times omega square.
R times omega square. Just 30 minutes back, I taught you normal acceleration. Are you following me? You were using the word radial acceleration. Who was our student? Yes. So you were actually right. Okay. Done. What else? Before I say goodbye, we have 2 minutes. What about you help me with the last portion about case B? Why don't you tell me AR? L theta, R double dot. Good. R double dot. Okay. Minus. Okay. L double dot. Okay. That's fine. L double dot minus L theta dot square. Okay. Done. What about A theta? L theta double dot. Okay. Plus 2 L dot theta dot. Okay. Any term that is 0 here? Do you see any term that is 0 here? No. And you see 2 terms that got 0 here. Okay. I know that you are wondering what on earth is this 2? How did you come up? We have all the semester to talk about these crazy things. Just remember that in polar coordinate system, this is how we approach. We have these 4 formulas. And before I say goodbye, we have 60 seconds. Just make this arrows in your notes. So next time I start from here. I am drawing an arrow outward. I'm calling it as E caret R. And 90 degree to it. 90 degree to it in the direction of increasing theta. I'm drawing my E caret theta. The normal acceleration was towards the center of curvature or away from the center of curvature? Normal acceleration. Normal acceleration was towards the center of curvature. Remember that? Okay. How did I draw E caret R? Towards the center or away? If you remember this, half the semester you understand. E caret R will be away. E caret N was towards. Bye-bye. Okay? Our class is over. Sorry?
Can you move this thing?
Yeah, I will.
So which one? What was E caret R which becomes?
E caret R is our radial coordinate. So radial coordinate is pretty much synonymous, you can say, with the normal coordinate. Our normal coordinate, the E caret N, was 90 degree to our tangential one, right? Here, same thing is happening. Here, instead of using T and N, I am using theta and R. My theta and R are again 90 degree to each other. My tangential, if you remember, I used to tell you that if the car is going in this direction, my E caret T tangential arrows were also towards that. Here I am saying my E caret theta will be towards the increasing theta. So for example, the bob is going anti-clockwise. So theta is increasing anti-clockwise. I quietly put my E caret theta towards it. So it's pretty much what I was doing in the TN. Here E caret R, I am putting opposite to the E caret N. And how do we reach to that conclusion? Just look at the AR. If you look at the AR, what is the AR in this case? Minus L theta dot square. Correct? Minus L theta dot square. So remember, my normal acceleration was V square over R, right? You remember that from your physics one. Instead of V, I substituted R omega. You remember that. I took a square, I put R or L, whatever. Agreed? Then I reach L theta dot square. So normal acceleration is L theta dot square. You and I agree. But if you look at here, what did I write? Minus L theta dot square. So normal acceleration was towards the center of curvature. Now radial, my radial coordinate is away from the center. Let's use the word center of curvature. But what is my AR? It is coming out to be, it is come out to be negative L theta dot square. So what the formula is telling me, you know what? You defined your E caret R outward. That's fine. But you remember that whatever acceleration this fellow is, it is towards the center. And we know that the normal acceleration is towards the center. You get my point? So polar coordinate system is exceptionally important. Actually, we finished our session 10 minutes early. So I thought that I should just tell you this. Yeah.
Could you please remove this part?
Yeah, sorry. Sorry for that. Okay. Have a nice day. Yes, you too. Thank you. Yes.
What's the difference from
Huh. I will tell you.
square and double dot?
What is the difference between?
Double dot and dot square.
Yeah, I will tell you. Look, whenever I have double dot, right? R dot, right? It actually means first time derivative. Okay. When I have R double dot, I will put d square R over dt square from my maths classes. So instead of have a nice day. Instead of using this, it will take a lot of my space in the board and even in your notes. So we remove this dt and we quietly put a little dot here. Similarly, if I have a second derivative of time, it will take a lot of my space in mathematics books. What they do is instead of second order derivative, on top of R, they put two dots so the student or reader understands that this is a second derivative of R.
This is acceleration.
Okay, now I will tell you the meaning of them. So your question is, what is the difference between like physically R dot and R double dot? So R dot actually means let's focus on this bob. If you even forget that this bob is going like this, if you focus on the fact that this bob is going like this only for now, we both understand that if it is going in this direction, then this R or length of it is definitely changing with respect to time. So your immediate answer will be, why don't you do a dl over dt if you want to find the velocity in this direction? So essentially this, where is that? This R dot is giving you the velocity of the bob in that direction. Velocity of the bob, actually, let me be clear, in this direction. Okay, in the radial direction, let's use the word. Now, what is R double dot giving you? R double dot again is the second derivative of R. And of course, it is also giving you the acceleration of this object in this direction. But you can also ask me that acceleration in the radial direction is R double dot. I agree. What on earth is this term coming? Because R double dot is easy to understand that the R or L is changing in this direction. But what about R omega square? That's a valid question, right? In order for you to understand R omega square, we will go back. Do you remember that when we were talking about normal acceleration, everyone said from physics 1, I have V square over rho. So there were quite a few students who started using the formula R omega square. I'm not sure whether you remember this from your physics 1. Does it ring bells? Yeah. Sure. Okay, I can even derive it.
Also square of VR.
Yeah. So V is R omega, V square is R square omega square, and V square over R will give you, I think we have do you have a class here? No. Okay, come. I don't think we have a class. We can talk about. So V square over R will give you R omega square. So you remember this, I will do a control Z. Now you remember this. So since you remember this, let's focus on the normal acceleration. Normal acceleration is in this direction. Agreed. Normal acceleration, where is the circle? Is in this direction. Oh God, I hope I saved those slides. Okay, I can talk from my head. So now you remember that normal acceleration is R omega square. So that formula that I showed you, that formula that I showed you, that A R is equal to r double dot minus r theta dot square. This r double dot, you know, this is that same r omega square. So one acceleration is because of the fact that this elastic band allows the bob to go 10, 10, 10, 10, 10. That is your simple r double dot. But this is coming from the fact that this theta dot, because this bob also goes like 10, 10, 10, 10. So whenever something is in a circular path, it always have that normal acceleration. Do you remember that? So this r double dot is coming from the fact that the bob wants to go 10, 10, 10. And this acceleration is the normal acceleration that comes from the fact that this object is going 10, 10, 10, 10. So automatically there is a normal acceleration component.
Okay hocam. So it's a square of theta dot.
R theta dot square.
Yeah.
So which is, if you remember, an equal to v square over rho, an equal to r square omega square over r and r omega square. So this is actually nothing more than your normal acceleration. And if you change this system to like this is going to be really nice, that if you change your system like this, rigid rod. So now the length of the rod is not changing. Okay, this is solid rigid rod. Now what will happen? Both of us know that now, excuse me, if this bob goes 10, 10, 10, 10, then you will also tell me that this bob is not going towards this or not going away, right? You will just tell me that this bob goes like 10, 10, 10. If now I ask you, do I have any acceleration in this direction? You will immediately tell me that since this bob is going in like 10, 10, 10 circular path, definitely I will have AR is equal to R double dot. Oh, no. It's a rigid rod. It's a rigid rod minus R theta dot square. Oh, absolutely. There is angular motion. I still have a normal component of acceleration. Similarly, A theta is equal to R theta double dot plus 2R dot theta dot. So you just keep playing with it. Did I answer your question?
Yes hocam.
Sure.
Yes. Hocam, at first time I was confused because there I see the dot and two at the same time, but I can understand.
Sure. It's just even the initial 7 minutes. I had extra 7-10 minutes left. So I just talked about it. Next time I will again start. We will go over it again. Huh? Don't worry even.
Hocam, also can I ask question about 206?
Yeah, right now, I will pause the recording because this is the dynamics. Okay.